Effects of turmeric, sambong, and bamboo as phytogenic feed additives on growth performance, carcass weight, and profitability of Cobb broiler chickens. Introduction. One of the most widespread food industries in the world is poultry, as chicken is the most usually farmed species. In particular, Cobb broiler chicken is one of the most popular and widely used strain of broiler chickens globally. They are characterized by their rapid growth, high feed efficiency, and large muscle mass, particularly in the breast and thigh areas, making them ideal for commercial meat production. In most countries, many antimicrobials or antibiotics are utilized to raise poultry. Antibiotic feed additives as growth promoters have long been supplemented to poultry feeds to stabilize the intestinal microbial flora, improve general performance, and prevent some specific intestinal pathology in poultry. Without antibiotics, sustaining the long-term capability of chicken meat production is challenging. However, antibiotic growth promoter use remains a significant societal issue. Antibiotic resistance in pathogens and commensal organisms is becoming faster because of the indiscriminate use of important antimicrobials or antibiotics. This will likely cause treatment failures and economic losses, and pose a risk of transmission in the food chain. Likewise, there are also concerns about antibiotic residues in animal and poultry products. Residues in livestock and poultry production can have an adverse impact on children. Worldwide, health-conscious poultry consumers have long called for the alternate use of natural additives to lessen the development and spread of multi-drug resistant pathogens. With the limited use of AGPs as food supplement, research on antibiotic alternatives has intensified remarkably in recent years. One of the most popular alternatives is the use of phytobiotics, or phytogenic feed additives, which is non-antibiotic growth promoters or groups of natural growth promoters used as feed additives. Accordingly, PFA includes a wide range of substances of biological origin, which can be divided into four groups: 1. Herbs; 2. Parts of the plant, whole or treated, such as roots, leaves, and bark; 3. Essential oils, such as hydrodistillate extracts, volatile plant compounds; and 4. Oleoresins, which are extracts based on non-aqueous solvents. Turmeric is a widely available medicinal plant and food item in Southeast Asia. Adding turmeric powder to poultry rations can improve the working system of digestive organs, which can help the absorption of food in the body and effectively decrease gut inflammation. Lumea balsamifera, known as Sambong, has been a medicine for thousands of years. It is known chiefly as Sambong in other Southeast Asian countries. Various experimental studies, both in vitro and in vivo, have reported the pharmacological activities of Sambong, such as antioxidant, cytotoxics, antimicrobial, antifungal, anti-inflammatory, and hypolipidemic. Common bamboo is the tallest grass in the world. It is widely distributed worldwide, and bamboo leaves have a long history of medicinal and culinary use in China. The bamboo leaves are considered antipyretic and diuretic. Also, it is considered for its anti-aging, antibacterial, and anti-tumor capabilities. Including bamboo leaves in the chicken diet increases body weight. Research gap and significance. To enhance the performance of agricultural livestock, natural medical products derived from herbs and spices have been employed as feed additives for farm animals. As such, growth promoters are incorporated into a nutritionally balanced diet to induce a response that enables the broiler chickens to reach their full genetic potential regarding growth and feed efficiency. Consequently, it is imperative to examine the potential of turmeric, sambong, and bamboo feed additives with medicinal properties as a safer alternative to antibiotics and to determine whether they can enhance feed efficiencies and promote rapid growth in broiler chickens. Research aims and questions. The study aimed to evaluate the growth performance, carcass weight, and profitability of Cobb broiler chickens with PFA diets containing turmeric, sambong, and common bamboo. Specifically, the study's research questions consist of: what phytogenic additive could increase the growth performance of broiler chicken? What phytogenic additive could increase broiler chicken's carcass weight? What phytogenic additive used is the most profitable for broiler chicken production. Methodology, duration and location of the study. The study was conducted from April to May 2023 at Pocho Alfonso Lista, Ifugao, Philippines. Experimental poultry house. A temporary experimental poultry house with 15 cages was used, each with a dimension of 1 by 1 square meters. Procurement of chickens. In this study, 125 Cobb broiler chicks were purchased. Environment, sanitation, and hygiene. 1 week before the arrival of the chicks, the experiment area and the premises were cleaned and thoroughly sprayed with disinfectant to prevent disease that might be present on the premises. Collection and gathering of phytogenic feed additives. Turmeric powder was store-bought, while the sambong and bamboo leaves were collected. Preparation of leaf meals. The fresh leaves of the sambong and the bamboo were air-dried, chopped, and milled to pulverized form using a corn hammer mill machine. This was mixed with the other basal feed ingredients to make a homemade formulated feed starter ration for the broilers. Experimental design and treatments. The chickens were randomly distributed into 5 treatments. Each treatment was replicated twice with a total of 15 experimental units. 8 chickens were assigned for each replication. The experiment was laid out using a completely randomized design with the following treatments. Treatment 0. Formulated feed ration without phytogenic feed additives. Treatment 1. Formulated feed ration with 2% chlortetracycline. Treatment 2. Formulated feed ration with 5% turmeric powder mill. Treatment 3. Formulated feed ration with 5% sambong leaves mill. Treatment 4. Formulated feed ration with 5% bamboo leaves mill. Feed formulation and mixing. A formulated feed ration was used after the 2-week brooding period. The formulated feed ration was used for 21 days. For the first 2 weeks of the brooding period, commercial chick booster feed was placed on a plastic auto feeder and was given for the first 14 days before transitioning to the formulated feed ration. Results and discussion. Weekly body weight. The average initial body weight of the experimental chickens ranged from 241.67 grams to 247.67 grams. In the first, second, and third weeks, the broiler body weight showed no significant results, indicating that the feed ration formulation for each treatment had the same effect on the body weight of the broiler chicken. Weekly gain in weight. There were no significant differences among the treatments. Across the 3-week trial, bamboo leaf meal consistently led to the highest weight gain in weeks 1 and 3, peaking at 475.67 grams in the final week. Chlortetracycline showed the greatest effect in week 2 with a gain of 419 grams, but its overall performance was outpaced by the bamboo-based diet. Turmeric powder meal and sambong leaf meal delivered moderate gains throughout, while the control group without leaf meal showed the lowest gain in week 1, but surprisingly ranked second by week 3. These results suggest that bamboo leaf meal may provide superior growth benefits over the other treatments tested. Average final weight. No significant results were observed on the broiler chickens. The highest average final weight was observed on experimental chickens fed with bamboo leaf meal at 1,588.83 grams, followed by chlortetracycline at 1,581.34 grams, without leaf meal at 1,554 grams, sambong leaf meal at 1,524.34 grams, and turmeric powder meal at 1,503.17 grams. Percentage rate of growth. Throughout the 3-week trial, no significant differences emerged in the percentage growth rates among treatments. In the first week, turmeric powder, sambong leaves meal, and bamboo leaves meal all outperformed chlortetracycline. In the second week, chlortetracycline took the lead at 56.50%, while turmeric, sambong, and bamboo fell behind. By the third week, turmeric and sambong remained below chlortetracycline's rate, but bamboo leaf again surpassed the antibiotic, recapturing its top position and underscoring its potential as a consistent growth promoter. Average weekly feed consumption. There were no significant results because of the small percentage of the added phytogenic ingredients, which may have affected their unpalatable taste. However, on a numerical basis, it is noticeable that the bamboo leaf meal has the highest amount of feed consumed with a value of 13,939 grams, followed by turmeric powder meal at 12,179 grams, chlortetracycline at 11,818.33 grams, Sambong leaf meal at 11,153.33 grams, and without leaves meal at 10,344 grams. Feed conversion ratio and feed conversion efficiency. There were insignificant differences between and among treatment groups. The without leaves meal showed the lowest final average FCR at 1.13 kg and highest final average FCE at 92.94%, followed by the Sambong leaf meal at 1.23 kg and 83.25% FCE, and chlortetracycline at 1.25 kg and 85.17% FCE. The highest FCR and lowest FCE percentages were observed in the bamboo leaf meal at 1.44 kg and 70.84%, followed by turmeric powder meal at 1.32 kg and 80.51%. Dressing percentage with and without giblets, liver and gizzard weight. No significant results were found on the male and female dressing percentage and their liver weight. On the other hand, a significant result was noted on the male gizzard weight. The bamboo leaf meal showed the highest weight of the male gizzard at 54 grams, followed by the Sambong leaf meal at 49.67 grams. The without leaf meal and chlortetracycline were the lowest at 41 grams and 40.67 grams. Percentage of cut-up parts. These parameters were percentage cut-up parts of the drumstick, thigh, breast, wings, back, and neck. There was no significant difference in the percentage of cut-up parts of both male and female broiler chickens, except for the percentage of drumstick, which showed significant results with the highest percentage treated with chlortetracycline, followed by without leaf meal, bamboo leaf meal, turmeric powder meal, sambong leaf meal. Profitability, return over chick and feed cost. The net income was based on the final weight of the broiler chicken multiplied by the price of 160 Philippine peso per live weight, the retail price at that time, which is less than the expenses on the feeds and the value of the day-old chick. The turmeric powder meal produced the lowest return due to its high cost among the phytogenic additives used during the feeding trial. Without leaves meal has the highest net income because it did not have an additional cost for phytogenic additives. Summary. The study's results are the following. There were no significant differences in the initial body weight of the broilers. Insignificant body weight results were noted during the first, second, and third weeks. The weekly growth percentage was insignificant during the first, second, and third weeks. The average weekly and total feed consumption was insignificant for all the treatments. The FCR and FCE were insignificant in all the treatments. The male broiler from all treatments showed significant results in terms of gizzard weight, but there was no significant result on the carcass weight, with and without giblets and liver weight. The female broiler from all treatments showed no significant result regarding carcass weight, with and without giblets, gizzard, and liver weight. The return above feed and chick costs showed varying results, with without feed additives having the highest return, followed by sambong leaf meal, bamboo leaf meal, and chlortetracycline meal. The lowest return was on turmeric powder meal due to the higher cost of turmeric powder compared to others. Conclusion. Phytogenic additives like turmeric, sambong, and bamboo can serve as effective alternatives to antibiotics in broiler diets, supporting growth and carcass quality. Bamboo showed better weight gains in some weeks, while sambong improved feed efficiency. These natural additives offer a sustainable and cost-effective option for antibiotic-free poultry production, though further research is needed for long-term use. Recommendations. Future studies should explore varying PFA concentrations, 10% or higher. Apply them across different feeding phases, booster to finisher, and extend the trial to 8 weeks for better observation of effects. Limitations of the study. The study was limited to testing 5% concentrations of turmeric, sambong, and bamboo as phytogenic feed additives in broilers. It did not consider other feed mixtures, higher PFA levels, or additional chick-related variables. Thank you for listening.